Dubai exists in a landscape of shifting sand and wind, but the city itself has become a massive thermal reservoir made of glass and concrete. Under a midday sun, dark asphalt surfaces absorb enough solar radiation to exceed 60 degrees Celsius, radiating a constant shimmer of heat distortion. This is the urban heat island effect. Human activity and built surfaces like roads and buildings trap thermal energy during the day and re-emit it into the atmosphere. In Dubai, this thermal mass creates a heavy thermodynamic penalty. At night, dense commercial zones stay 4 to 7 degrees Celsius hotter than the surrounding desert. This reaches a strict biological limit. Climate models project that by 2070, parts of the Gulf will likely exceed the human survivability threshold of 35 degrees wet bulb temperature. The science translates to acute physical risk for anyone working outdoors. Construction and sanitation workers in the region face 2 to 3 times the baseline risk for kidney and cardiovascular strain during summer peaks. The macroeconomic drag is measurable. Heat-related productivity losses across the Arab states are estimated to cost over $10 billion every year. To maintain indoor habitability, the UAE relies on a massive energy draw. Space cooling alone accounts for approximately 70%. This is Singapore, a city-state that successfully engineered urban cooling at a national scale. Despite high humidity and constant 30-degree temperatures, they turned heat mitigation into a core planning strategy. The Cooling Singapore initiative achieved a measurable result, reducing outdoor thermal stress in pilot zones by approximately 4 degrees Celsius. Applying these lessons to the UAE requires geographic adaptation. A water-rich tropical solution cannot be directly exported to a hyper-arid desert. On our Dubai city block, the first layer is material replacement. Switching dark surfaces for high albedo and phase change materials reflects solar energy back into space, lowering surface temperatures by 5 to 10 degrees. The second layer is the integration of shaded walkways. These structures protect pedestrian corridors from direct radiation, making walking a viable transit option even in the heat. Third, the block needs vertical greenery. This reduces the cooling load of individual buildings, but in an arid climate, it must be limited to drought-tolerant, climate-adapted species. To protect limited water resources, the irrigation for this urban greenery must be legally mandated to use treated greywater systems. Reflective materials and shade create a cooler physical baseline, but they are passive. A truly smart city needs to actively manage its environment in real time. This creates a digital nervous system for the city block, connecting physical infrastructure to an invisible data mesh. Citywide AI sensors measure air temperature, humidity, and surface heat in real time. This data allows the municipality to track heat exposure at the street level and deploy mobile cooling or alerts to protect commuters and outdoor workers. This technology integrates directly with transit nodes. Dubai's existing bus shelters can be upgraded with solar power and mist cooling systems that activate dynamically when the sensor mesh detects a temperature spike. The digital network moves inside the buildings through the implementation of upgraded smart building codes. Mandatory IoT-based building management systems reduce the strain on the national grid by tying air conditioning output directly to real-time room occupancy. Combining phase change materials with AI sensors provides the technical capability to lower urban heat. However, that capability only matters if the state creates the economic leverage to compel construction. The primary bottleneck for climate infrastructure is that the private entities required to build it often face immediate financial disincentives. Regulators like the Dubai municipality champion the cooling agenda, but they lack the private capital to reconstruct the city alone. That capital belongs to real estate developers and utility companies, groups that have historically resisted immediate, high-cost mandates. This stakeholder matrix maps these groups by their level of influence and their underlying financial interests. Conventional developers face higher upfront material costs for cooling-grade pavements and green roofs, which can reduce their immediate profitability on a project. Utilities face a separate conflict. While a cooler city stabilizes the power grid by reducing peak load, it also cuts the revenue they earn from raw electricity consumption. To align developers, the state offers incentives like floor area ratio bonuses and fast-track permits, which increase the long-term value of the building to offset the initial construction costs. To align utilities, the state shifts to performance-based regulation. Instead of being paid for the volume of energy sold, providers are financially rewarded for grid stability and peak load reduction. Effective urban cooling is not just a technical challenge, it is an exercise in precise financial incentive design. The central weakness in the current approach is that cooling initiatives are split across multiple competing agencies. Consolidation is the final requirement. A unified smart cooling operations center must operate under a single citywide authority. This command center ingests the data from the street-level IoT mesh to coordinate transit, utilities, and municipal planning in real time. This unified system produces measurable outcomes over a 5-year timeline: a 15% drop in peak cooling demand, a 2-degree reduction in average ambient temperature, and total shade coverage for priority public walkways. These results create significant secondary benefits, including lower hospital admission rates and an extended tourism season as outdoor spaces become more comfortable. This infrastructure work provides the measurable progress needed to back the UAE's international climate commitments and the legacy of its COP28 leadership. Because space cooling is the largest driver of emissions in the region, this is the most effective lever for achieving the UAE Net Zero by 2050 strategic initiative. Heat is the defining geographic limit of the Gulf. By engineering a smart, incentivized cooling system, the UAE transforms its most severe vulnerability into a blueprint for sustainable urban life in a warming world.